Okay, so today's lesson is going to be on using significant figures during a multiplication or a division problem. Now, regardless of whether you are multiplying or you are dividing, the process is going to be the same. So let's look at our first example. 2.85 times 1.5. When you put this into your calculator, you end up with a value of 4.275. Now, how are we going to figure out our answer to the correct number of significant figures? And that's going to boil down to our numbers that we started with. These are essentially like calculations or data that you would have collected in a lab. So it's based on the precision of the instrument that you used. So 2.85 was collected in the lab with an instrument that is more precise than the 1.5 value was collected. All right, so our final answer cannot be any more precise than the least precise piece of equipment. So what we're going to do is we're going to look at 2.85, and we see that 2.85 has 3 significant figures. And 1.5 has 2 significant figures. So the lowest value here is a 2, meaning 4.275 can only have 2 sig figs. So that's going to be 4.2. And in math, we always go out 1, and this 7 is going to round the 2 up to a 3. So my final answer here would be 4.3. Let's do one more example. All right, 6.40 times 2.301. So when I put this into my calculator gives me 14.7264. My first value has 3 significant figures. This 0 is significant, and if you need to go back and rewatch the video on how to determine the number of significant figures. And 2.301 has 4 significant figures. So when I look at this, my lowest number of significant figures is 3. So 14.7264 can only have 3 significant figures. That's 14.7. We're going to go out 1, and that 2 is going to round the 7 to stay a 7. So 14.7.